Okay, alright, hi and welcome back to our chemistry SPM channel. So for today, I'm going to explain to you about Voltaic cell. Okay, so basically this video would be fully in English because the DLP students requested me to explain the Voltaic channel concept in English version. So this video is one of the basic examples for my tuition students. I would show one example from this 4 questions for you to learn the answering techniques, and the remaining 3 I want you to answer by yourself and show to me in the tuition class later. Okay, and for the others, if you want the PDF that I prepared with a compilation of few Voltaic style questions, you can request in the comment box. I will post for you. Okay, so as usual, in my left hand side, I already have the question. In my right hand side, I'm going to write the answers for you, so you may take a look in the answers and make sure you understand what you're doing. Okay, I will give the tips to answer first, then only I will go for the answers. Alright, okay, so there are 4 questions here, but I specifically want to choose question number 3 for you to give an example and basic view how does Voltaic cell question looks like. Okay, so first of all, I want you to copy whatever I'm writing in the screen right now. Okay, first I give you the tips lah. Okay, tips. Okay, I rewrite it again. First tips. Okay, as for the tips, the first thing that you should do when you got the diagram like this is you should determine the anode and cathode, or in other words, we call anode as negative terminal and cathode as positive terminal. So determine anode and cathode. That should be your first job. Okay, that should be your first job at first lah. Okay, so usually your anode, people will call your anode sometimes as negative terminal. It's just the same only, just the same meaning, same word, just different spelling. Okay, so anode sometimes people will refer that as negative terminal, and cathode sometimes people would refer it as positive terminal. Why they refer as negative and positive terminal? Because anode will have anions. That's why we call that as negative terminals, because the anion have negative charge. While your cathode, they like to keep your cation, which is your cations are positive in terms of charge. So this is the first reason that you should do. Okay, so how to determine anode and cathode? Okay, so I write at number 2. If let's say your E0 value, okay, you have the standard electrode potential table, right? Make sure when you're doing the exercise, the table is beside you. You can print out a table. Like for my tuition students, I already print out for them the table itself, so you can put it beside you, then you do the questions while watching the videos. Okay, so if let's say the E0 value more negative, okay, more negative or less positive, just the same thing only, it will go to anode. If your E0 value more positive, then it will go to your cathode. Okay, this is your second tips. Then your third one is your process. Okay, you should tell the process that occurs in anode and cathode. Okay, so you know the process that occurs is only 2, either reduction or oxidation. Okay, so how to remember what happens at cathode and what happens at anode? Okay, so this one I have a mnemonic. I would say that like this: anox, red cat. Okay, so anox, red cat is a mnemonic where your AN stand for anode. Okay, anode, and the OX beside that stand for oxidation. Meaning that after you choose your ions at your anode, you should remember that at anode always oxidation will happen. In electrolytic cell or chemical cell, at anode always oxidation, while at a cathode always reduction. So red stand for reduction. Reduction occurs at where? At cat. Cat means cathode. CATHODE. Okay, so this is how I remember. Okay, this is how I remember the process that occurs at anode and cathode. Okay, anode always oxidation, cathode always reduction. So after you know this thing, then only you can proceed answering the further questions, the remaining questions. Okay, so you have two electrodes, magnesium and argentum. So where should I get the E naught value? That should be my first question. Okay, where should I get my E naught value? Because I don't have my E naught value right now at here. But in your exams, they will give you the table. But yeah, I just crop out the question. I didn't crop out the table. Okay, so let me to show you. Open your textbook lah. Okay, so textbook. Okay, so let me to go to this page. Okay, you can see here. Okay, I have magnesium and argentum. Okay, try to see magnesium first. Magnesium is negative 2.38. Okay, right at the electrode magnesium, negative 2.38. Okay, and then your argentum is positive 0.80. Okay, so after that, okay, after you write this, then go back to your question. But before that, you see, the main thing in Voltaic cell is the electrode and the cation in the solution would be same. Meaning that, okay, now I have what electrode that I'm pointing out in my screen right now with my cursor. Yes, I'm having magnesium electrode, right? So that magnesium electrode would always immerse, akan dicelupkan dalam larutan yang mengandungi ion magnesium in the solution that have magnesium ion. So correct lah, the solution have magnesium ion. It can be any magnesium, magnesium sulfate, can be magnesium nitrate, can be magnesium chloride, can be magnesium carbonate also. But as long as we want the electrode and the cation should be same. Let's say I have electrode magnesium but I use potassium, Kalium, Salah, it's wrong. It should be magnesium. Same goes to this side. If the electrode is argentum, then the solution should have argentum. Tak kisahlah argentum apa, argentum nitrate ke, argentum sulfat ke, argentum chlorida ke, whatever argentum, as long as it's an argentum. Faham tak? So lepas tu, this is the basic concept lah. So I go back to my question. Oops. Okay, now you can see everything in my tablet already lah. Okay, so lepas you child the process and you dah determine your anode and cathode everything. Okay, now dah determine anode cathode kan. Okay, lepas tu dah bagi tahu dah what will happen. Anode akan berlaku oxidation, at cathode akan berlaku reduction. Okay, after that what you should do is you should tell half equation. What is half equation in bahasa Melayu? Half equation is your setengah persamaan. Where should get the setengah persamaan? Okay, the setengah persamaan don't need to memorize. It's already have in your standard electrode potential table. Just use that. Okay, tak perlu nak hafal. Just take it. But ada issue kat sana. Okay, what is the issue? Okay, I tell you the issue. Okay, so ingat for oxidation, I would say reverse equation. While for reduction, I would say copy back equation. Okay, copy back equation. Okay, what does reverse equation and copy back equation means? Okay, you have your standard electrode potential table, right? Okay, let me to show you again. Okay, I show this side lah. Okay, this time I show at this side. Okay, just a minute. Okay, okay, this is your standard electrode potential table, correct? Okay, where is my cursor? Okay, so if let's say you're doing for magnesium, I'm showing, right? Okay, so after you determine which one is anode and cathode, okay, remember that all the equations that they gave here, only equations, kalau oxidation you kena terbalikkan, because all the equations here are for reduction only. So if let's say, for example, you punya equation, okay, saya ambil K plus lah. Okay, K plus kalau for reduction we will tulis K plus E equal to K. Kalau reduction, let's say it happens oxidation pula, kat sana berlaku oxidation, I terbalikkan K equal to K plus E minus. Ni untuk oxidation, yang ini untuk reduction. That's why I say you should be careful when giving the answers. Okay, so the main aim in your 1.2 subtopic is to teach you how to use standard electrode potential table. So if you manage to use the table correctly, then it's not a big issue for you. Is it clear for you? So make sure you remember, electrode potential table, everything is for reduction. So let's say dia minta for oxidation, you terbalikkan dia dari equation. So I already teach this for my students during their electrolytic cell. I teach them electrolytic cell dahulu, then only Voltaic cell. Sebab electrolytic hard a bit, Voltaic senang. That's why I teach them electrolytic. So in electrolytic I dah beritahu dah, kalau oxidation you kena terbalikkan your equation. Kalau reduction, copy saja macam tu, tak payah change position. Okay, and then after that, number 5. Number 5 is your overall ionic equation. So after your overall ionic equation, then you should do cell notation. Okay, remember that I will teach you what is cell notation in a while. Okay, for your electrolytic cell, you don't have cell notation. Cell notation only for your Voltaic cell, which is cell yang kita belajar sekarang. Okay, and then finally you will do calculation for E0 value of the cell. Basically, in the table, you are the E0 value for, you are the E0 value for each of this electrode. But now, both of them combine together in one system. So, the final step is we will calculate the E0 of both of them together. Okay, so for the number 7, we have a formula. For number 6 also, we have a formula which you should remember. Okay, so the formula, I beritahu you siap-siap, nanti you can use. I would say ABC for cell notation. Okay, B ni bridge. So before bridge, you will place your anode, and after bridge, kira C ni you akan place your cathode. Okay, so that should be your, what you call that, your mnemonic to remember. So I would say anode, bridge, cathode. Okay, and then next, calculation for E0 of cell, right? Okay, calculation E0 for cell is actually your formula. So your formula is actually as simple as this. E0 for the cell equal to E0 at cathode minus E0 at anode. This is the formula. Ingat that if let's say your anode they have a negative value, the negative is not same with this minus. Ini tolak. Okay, this tolak is an operation, operasi. So operasi tu you just kekalkan like this lah. Okay, let's say cathode punya value X. X apa? Positif ke negatif? You tulis. Tolak. Okay, let's say your E0 ada negatif. Tulis E0 tu letak Y. Faham tak? Jangan combine negatif ni dengan Y tu. Okay, so make sure you take the value in the electrode potential table with the plus or minus sign. Ingat, in mathematics you can ignore the positive sign, but in chemistry no, you tak boleh ignore. You kena tulis the sign. So make sure you write the sign. The main purpose of us asking you to write the sign is so that you tahu apa yang you tengah buat. So make sure you do like that. So I erase this one, then I go for the example. So I bagi tips pun dah panjang dah, the basic tips pun. So tak apalah. You know what? I sum up this video. It's okay. Dah sekarang pun dah 13 minit. So I settlekan this video. Next video, we will discuss, about the Voltaic cell. We will discuss how to do the questions step by step based on this guideline. So for those yang nak this guideline, can let me know in the comment box. For those my tuition students, I'll give you the PDF. And for those that interested nak join my online tutoring class, can let me know. You can text me. My number is there. Or let's say you can't find my number, just comment down in the video. Any videos, I can come reach you and give you my contact number. You can contact and join my online class. I'm offering one-to-one online class and also group classes as well. So up to you lah, you nak join yang mana. And remember, my classes adalah separate. Maksudnya I tak combine DLP and non-DLP. I don't combine. DLP is fully DLP, Malay is fully Malay. I don't combine the classes because I know it too will be very hard for students to understand. So make sure you can faham lah what I'm talking about and write all the tips that I give sekarang ni for your SPM. That's it from me. Bye bye.